Next, let's switch over to the native SDKs. We all love our modern apps and devices. They keep us connected, productive, and engaged. With full access to the device hardware and sensors, native apps feel like they belong on the device. They're not just displayed on it. Using the native SDKs, developers can build high-performance mapping applications that integrate deeply with the device platform and extend the reach of WebGIS to your custom apps. With options for .NET, Flutter, Kotlin, Qt, and Swift, developers can use their favorite tools and frameworks to build either cross-platform or platform-focused applications and get access to the same set of capabilities. The native SDKs are built from the ground up to work offline. This isn't a workaround or a fallback. It's a core design principle that's pervasive across all capabilities. With flexible patterns to provision the data, your applications can download map areas on demand over the network, or you can deploy the data directly to the device for fully disconnected scenarios. Everything the app needs is right there on the device to display and query, to analyze, and even edit. With a fully featured mobile geodatabase, apps can easily collect new data in the field and synchronize them over the network with feature services. And thanks to a mobile-friendly geometry editor and customizable forms, you can streamline the data collection workflow to suit your users' needs. To take a look at just some of the enhancements we've been making in these areas, I'll pass it over to Lucas.
Thanks, Divesh. Collecting and editing data in the field is critical for many organizations' workflows, but building great user experiences on a touchscreen device can present some unique challenges. I'm going to highlight 3 enhancements we've made that will help you make great editing applications for your mobile devices. First up, we have the Reticle tool. The Reticle is a geometry editing tool purpose-built for touchscreen devices. Its fixed location in the center of the screen allows you to easily see your edit, along with any snapping feedback, without your fingertip getting in the way. We heard feedback from you that you'd like more control over the behavior of the reticle, so we took that feedback and came up with the Programmatic Reticle. With the Programmatic Reticle, you can define your own experiences, like this one, where we have an action button that changes depending on the hover state. Currently, you can see that the reticle is in insert mode. If I tap my button, a vertex is inserted. If I move the reticle back over an existing vertex, notice how the button changes. It's now in pickup mode. I can tap the button to pick it up, pan the map, and tap the button again to put it back down. Finally, with the Programmatic Reticle tool, you can override all the gesture behaviors, such as the tap event. In this app, I've wired it up so that if I tap on a vertex, I'll center my reticle directly on the vertex. This makes it really easy to traverse and edit my entire geometry. Using the hooks provided in the Programmatic Reticle tool, you can build great user editing applications for your mobile devices. Next, we have group and preset templates. Consider a utility worker tasked with adding gas service lines to houses in a new subdivision. Traditionally, for each new house, the worker would need to add a service line, a T connection, an excess flow valve, and a service meter. This is time-intensive, and it's error-prone. With group and preset templates, we can simplify that to 2 taps on the map. Here I can see all of the templates defined in my map. I'll start by searching for my service pipe group template. The group template will contain all of the sub-feature templates, as well as a primary geometry and a sketching tool needed to create all my features. I'll select my template and a tool, and with the help of the reticle and snapping, I'll sketch a line. When I finish my edit, you can see that all 4 features are created. I have the service pipe, excess flow valve, meter, and T all created in the right locations relative to each other. They have the proper attributes and symbology. And if desired, I can open up the feature form for each individual feature to make further edits. As you can see, using group and preset templates can dramatically simplify data creation. Lastly, we have editing associations and feature forms. Feature forms are user-friendly interfaces for editing attributes and attachments in ArcGIS. Through the power of Arcade, you can set conditions that will hide and show fields and auto-populate values, streamlining data input. Feature forms also support advanced data models, like the utility network. Here, I'm looking at a feature form for a streetlight in an electric data set. I can view and edit attributes, as well as associations and attachments. When I open my attachment, I notice that this streetlight is mounted onto a pole. Within the utility network, this is typically modeled as 2 separate features with a structural association between them. Back in my form, I can see my structure association, so I'll tap that, in this case, a structure junction to an electric low voltage pole. I can show my associated feature on the map and access its feature form to make an edit. If desired, I could add or remove associations to other features as well. Today, I've shown you 3 enhancements that will make it easier than ever to perform sophisticated editing workflows on a mobile device. Now I'm going to pass it back to Divesh to show us another demo. Divesh?
Thanks, Lucas. In our last release, we added support for Geospatial PDFs, which is a common format used by many of your organizations. In US wildland fire operations, they're used to distribute incident action plan maps, like the one we see here of Canyon Fire. The blue dot shows my location, and the incident map helps me to understand things like the extent of the fire perimeter, shown here in red, and the location of drop points for essential personnel and supplies, shown here by the blue squares. Because incident maps are distributed in a standard format, they can be used across a variety of applications and can easily be shared with teams and organizations to provide a critical operational context. There are many ways your apps can import PDF files. In this case, I've already downloaded the latest incident map from the FTP site and saved it on the device, so I can go ahead and import it into my application and add it to my map as a new layer. This incident map is from August 9th. By adjusting the layer transparency, we can see just how the situation has changed in one day. Let's take a closer look. We can see that between August 8th and 9th, drop point 6 has been added to the western edge of the fire perimeter. And just south of it, a portion of the fire perimeter shown in black has been contained with control lines. In situational awareness applications, it is vital to have the latest information so you can make timely and well-informed decisions. And Geospatial PDFs give you another great option to put authoritative data into the hands of your users. Those were just some of the ways in which we keep enhancing offline-enabled workflows that are central to your applications, whether it is mobile data collection in the field or delivering situational awareness. As we saw in the game engine section, 3D is a really powerful way to visualize your geographic data. And the native SDKs allow you to easily explore and interact with 3D scenes on your high-resolution devices or overlay them on top of the real world in AR. Your applications can effortlessly stream 3D data from the network or directly from files on disk without dropping frames, even when the network drops. And the 3D scene is rendered with such high precision that you can do things like make measurements, predict shadows, and compute visibilities. But it's not just about pushing pixels on a screen. With access to the underlying data, you can use analysis to turn data into insights and information into decisions. Whether it is tracing along utility networks, calculating optimized routes, or monitoring geofences, all the analysis is done locally on the device, giving you blazing fast results. And in our upcoming release, we'll be pushing the device GPUs to the max by adding an amazing new set of capabilities to display rich 3D content and work with spatial analysis directly on the device. To show us a preview of some of these capabilities, I will pass it to Ralf and Thad.
Thanks, Divesh. At the next release of the native SDKs, we will be adding a new view, the local scene view. This view will allow you to load web scenes authored in local mode, or you can create your own. Local scenes are specifically designed to work with local 3D data in the coordinate system of your choice. This is especially important for architecture, engineering, and construction workflows, where teams need to visualize and inspect detailed building and infrastructure models in real-world scenarios. Here on my tablet, I've loaded a local scene and zoomed to Ouray, Colorado. I can clip my scene to focus my work area and provide better context for my app users. Let's go ahead and explore this scene. You immediately get a sense of realism. Terrain has depth. We've added full edge rendering support, which makes these reference buildings here really pop. We've also added support for multi-LED models. Models further from the camera will show at a lower fidelity, whereas models closer to the camera will show at a higher fidelity. And this threshold changes dynamically based on the density of my scene. If performance starts to suffer, we'll favor the coarser models. We've also added support for materials, making metallic surfaces like this car shine, whereas this picnic table over here has a rough, textured, matte sort of look to it. We've also added support for emissive properties. Let's see that in action. Here, my scene will transition from day to night. Shadows move as the sun crosses the sky reddens as the sun sets, and my city lights up as the scene gets dark. The local scene view supports building scene layers, and those are the detailed building models that I mentioned earlier. You can apply filters to these buildings and enhance these filters with different rendering modes, such as wireframe, so you could really explore the inside of your building, or X-ray to focus your view. You can identify, select, and explore your pop-ups with these buildings. This scene contains well over 20,000 features in it, which results in about 60 million rendering primitives. It's quite a bit, yet my interactions are still smooth and snappy. This is because the local scene view is powered by an entirely new rendering backend designed to leverage the power of modern desktop and mobile GPUs and rendering APIs. The design efficiently uses device resources, maximizing your battery life, all while preventing this device from getting super hot while I'm using it. Because these are things we have to think about when we're building apps for mobile devices. And with that, I'll pass it over to Thad, who will demonstrate some additional native SDK up-and-coming technology.
Thanks, Ralf. The new high-performance spatial analysis API for our native SDKs leverages the device GPU to perform incredibly fast and responsive analysis. It provides a framework that allows you to chain together tools and operations, combine analysis from several input data sets, and quickly produce a result. Let me show you an app I've put together that highlights some of these features. My app displays a map of Arran, an island in western Scotland. It uses a 10-meter resolution elevation data set to create a viewshed for a location tapped on the map. The viewshed is updated as I move my finger across the display. Now, I can't quite count this fast, but I'm told it's about 15 milliseconds to create a new viewshed at each location. With using local data on the device makes it even more performant. And it also allows you to perform analysis when you're disconnected from the network. Resolution of your analysis results is at the full resolution of the data, not the display. That means your results are consistent and accurate. Since all of the spatial analysis operations are implemented as a compute shader, a program that runs directly on the device GPU, display performance is amazingly fast. Okay, so that looks pretty good with one viewshed getting created dynamically. What if we were to have several viewsheds being updated? Like, for example, tracking a fleet of drones and evaluating which areas of the terrain are visible. My app simulates the display of 14 drones moving across the island and creates a viewshed for each drone to show the visible areas. Each drone updates its viewshed 20 times a second, which means my app is creating 280 viewsheds every second. And yet, as you can see, performance is snappy. But I still need to show you one of the more powerful aspects of the API, which is the ability to chain together tools and operations to get a result. I'm going to define an expression here that will be evaluated using map algebra and then incorporated into my analysis. In this case, I'm going to indicate that areas classified as forested in a separate land cover data set from the Living Atlas should be showed as obstructed in our analysis. And when I apply that, you can now see I have a new category of visibility showing me areas of limited visibility here in pink. Process chain optimization in the API means that regardless of how many operations I chain together this way, the compute shader that runs them will be recompiled on the fly and executed once, so performance remains excellent. I've shown you how the new Spatial Analysis API provides a set of tools and map algebra operations that you can chain together with several input data sets to produce your result. This API allows you to build applications that haven't been possible before. The resolution of your analysis results is at the full resolution of the data. It can be displayed in 2D or 3D. In addition to displaying your results, you can export them to a file and persist them on the local device. To bring it all together, the API leverages the power of modern GPUs and display pipelines for lightning-fast performance. Back to you, Divesh.